Hey everyone, welcome. For those of you who don't know me, my name is Sam. I'm on the Work on Climate events team, and we're super excited to introduce Levi and Sam from Pachama. I know none of you guys came to hear me talk, so I'll keep it brief. Um, Basically, Sam and Levi are planning a fairly short talk, I think 15-20 minutes, and then we can have the rest of the time for Q&A, which is great. And like Levi was saying, it'll be a fairly technical talk. Unfortunately, my background is mechanical engineering, so I have no idea about anything to do with AI, machine learning. So I'm really going to rely on you guys to ask as many amazing questions as possible, and I'll interject if necessary. And then the last thing I'll say is, due to multiple requests, the event is being recorded. And if you don't want to be recorded for whatever reason, just please let me know in the chat. I'll stop the recording immediately and delete it. But if you are comfortable with it, it would be really awesome for the people who couldn't make it and for future viewers. So with that, I'll hand it off to Sam and Levi.
Cool. Thanks for the intro, and thanks for give us the opportunity to chat and tell a little bit more about Pachama and what we're doing here. So I will present my screen. Second. So I am Levi. I'm a software engineer here at Pachama. I joined in January. The company was, I think, 6 people before me. So I've been here for a while, in I guess terms of the life of the company. Previously, I was at SpaceX. I guess the posters gave it away. And then also I did a stint in executive coaching at BetterUp before making my way here to Pachama. So across those companies, I've done a lot of different things, but software mostly. And then I'm presenting here with Sam.
Yeah, thanks, Levi. I'm Sam Brotherton. I actually joined Pachama significantly more recently than Levi in the scheme of things in our company. I joined back in July, post-COVID. And prior to that, I was at Google for a while doing ad targeting, and then I decided I wanted to get out of that world and help with something other than targeting advertisements at you, and found Pachama. And yeah, it's been fantastic. I focus on machine learning and data engineering on the most part. One thing I'll add is that we don't have, I do much more of the data engineering side of machine learning, and we don't have on this call someone from the science point of view, but if you have any questions about that, I can forward them to one of our colleagues. You can get that question answered for you too.
Yeah, great point. And then so for this presentation, I'm going to give over like a high-level overview over the Pachama as a company and kind of our vision, and then we'll quickly go into the technical side of things and more of what we're doing on engineering stuff, like engineering side of things, and the challenges that we're kind of working along in that space. So at Pachama, our vision is to fight climate change through restoring nature, really the preservation and restoration of nature. How we've targeted or contributing to that is through 2 avenues, specifically for forest projects and carbon markets. So we're developing artificial intelligence to monitor forest projects, using any remote sensing data we can grab our hands on, but mainly satellite images and LiDAR and forest plots collected by hand, to build artificial intelligence models to really track the evolution of forests on Earth. That's really important in carbon markets, because a forest project is going to get issued carbon credits based off how much carbon is stored in that forest and whether it's being preventing it from being deforested or actually growing trees. The second part is to build an online marketplace where we actually sell carbon credits from those projects, such that individuals or businesses can come to our site, find high quality carbon credits, and have them retired on their behalf. So we're really trying to make the process as transparent and really seamless as possible for end users, whether it's an organization or an individual. Compared to other carbon credit schemes, I think a lot of people are concerned about forest projects being non-permanent, or like what happens if someone gets issued carbon credits and then the forest gets cut down, things like that. So those are some of the problems we're trying to address. And from this like remote sensing data that we can have, and this is just satellite right here, you can start to like paint really cool pictures of forests over time. So this is I think this is a reforestation project that's a collection of individual landowners, if I'm remembering this one correctly. But just from the satellite imagery, you can really see, you know, just like with the eyeball test here, that like the project and these red brown trees here are regrowing at a significant rate compared to that in the region. In this case, this is really awesome to see. Like do see a lot of regrowth over time, and this may be, you know, 15, 10 years. But through the satellite imagery, you can really start to see this evolution and start tracking some of the stuff. And it's really cool to see the tangible effect of these projects on the landscape. And there's almost every project that we have on the platform have these really cool GIFs associated with them showing this stuff. Some of them aren't on the platform, but these are the kind of trends that we're looking for. And then for once we can get our hands on LiDAR data or some other like higher fidelity or remote sensing data, we can start to really estimate in a high level way or high accuracy way how much biomass is stored within this project. And then that directly relates to the carbon credit issuance and the whole carbon credit market process. And then here's some other examples of how you can start telling the story of these projects over time. So in this left-hand example, this is an avoided deforestation project where you can see heavy deforestation coming in from the south. And then this project's established. And while there's still deforestation, unfortunately, happening in this region, you can see that this project, this is like pretty well maintained at like with almost no deforestation rate. It's pretty incredible. And then here on the right-hand side, you can see this is a project where you can see deforestation all around the region, these lighter areas, and then it starts coming into the project, which was not planned. So through this satellite imagery, we can start saying like, hey, we've noticed that there's been some disturbances in the project. You know, we can reach out to the project developers and ask them, you know, if they've known about it or like what they're doing to try to prevent it, as a way to, you know, help them prevent this stuff, and as a way to hopefully help keeping them accountable to the people who are buying credits from those projects. So but again, like the people who are buying carbon credits, or the businesses especially, this is like what they're concerned about of, okay, how do I know that this carbon credit I'm buying actually means that a ton of carbon was sequestered or prevented from being emitted in this forest? This is also important too when you start thinking about things like natural risk. So something that is top of mind, I think, for all of us just coming out of fire season is wildfires. You know, California is seeing some of the largest fires ever. So a common question people come to us with, like, hey, is that project that I bought these carbon credits from, is it okay? So, you know, through this tracking of this imagery and some other like data sources, we can start, you know, monitoring these things, detecting them, and notifying not only the project developers, but also the buyers, seeing like, hey, this is what's going on. This is how the project developers handling it. You know, in the event of a reversal, this is what happens. And we can start walking them through that process and taking away some of the fear around forest projects in general. So on the technology side, there's a lot of challenges when you start thinking about this kind of global monitoring of forests. So here I'm going to hand it over to Sam to kind of walk us through some of those challenges.
Thanks, Levi. So yeah, I'm going to start out on the machine learning and AI side, and then transition into kind of taking a step higher, the challenges that we are facing on just aggregating all of the data necessary to even run these algorithms. And then finally, Levi will pick back up on the accounting side, which has equal challenges. So So on the AI side, most of the questions that we're asking of our verification technology boil down to being able to, for any given perimeter on the Earth, whether that's a 1 hectare or an entire project or the entire Amazon rainforest, being able to estimate the biomass of that area, and in general being able to estimate the structure, the forest structure, right? And we have we have quite a few different data sources that we use to try and do that. So the most accurate, closest thing to ground truth that we have is field plot measurements, and that is the traditional way of measuring a forest. It literally entails sending a team of people out to measure trees, compile everything into a spreadsheet, and then estimate biomass that way. Obviously, that doesn't scale to auditing, millions of hectares of forest and projects on a monthly or even yearly time basis, and that's root cause of a lot of the issues that we're seeing in these projects that Pachama is trying to fix. So we use, instead of that as the only source of truth, we use it as the source of ground truth, and then attempt to use remote sensing data to train machine learning models that predict the same biomass scores. Of that data, we have optical and synthetic aperture radar satellite imagery, which is largely available from public sources like Landsat, Sentinel, and lots more public sources growing every day. We also have, at a step closer, higher in accuracy, but more expensive, we have airborne LiDAR, and that's people literally flying drones or airplanes low flying over the forests and collecting point cloud data with LiDAR scanners, which provide a really accurate way of estimating biomass as well. And then finally, all of this remote sensing data has to be combined with what we know about the ecosystem, the environment, and the underlying terrain as well. Because particularly in the case of LiDAR, you take satellite LiDAR, we might have a very coarse point cloud, and we need to determine whether a given point represents the canopy of the forest, which is something we're interested in, or if it represents just the ground, right? And there's all sorts of ground interference calculations that you have to make that depend pretty heavily on the terrain of the data. So yeah, estimating forest structure with all this data is kind of the core problem. Sub-problems include, well, say we have 1,000 different satellite images over a year of the same area, taken with different sensors, maybe with different weather patterns. Combining those into a single normalized image that can then be thrown into our machine learning algorithms is actually a pretty significant problem as well. So we're experimenting with some deep learning approaches to do that normalization. Style transfer seems to be working pretty well, and we're investigating cycle GANs as well. And then finally, what I talked about is the ground truth measurement, those field plots. They're not really ground truth in the sense of biomass per hectare. They're really circumferences of trees, right? So backing into biomass from that data is an interesting problem in and of itself, and we've been using some statistical methods like Gaussian processes to do that. And then on the data side, which is more what I've been working on, we have some benefits that a lot of companies don't have. The first and foremost being that there is absolutely massive amounts of freely available data from governments around the world, right? Like Landsat and Sentinel 1 and 2. There's no shortage of data. But with that comes issues. I mean, first off, we can't afford to even store petabytes of data, let alone run processing on it. And second off, every government in the world has their own data repository, which can be really slow. It can be capped sometimes. It can be flaky and go down every other week. And we have to deal with all of those technology issues and opportunistically cache the data that we care about in order to run these analyses. And then finally, we're lucky enough to have access to a tool called Google Earth Engine, which I'm sure a fair number of you have used before. It's fantastic, but it also is a pretty severe bottleneck when you're trying to run planetary scale algorithms. So we're gradually trying to build our own data layer, build our own data compute layer, but it's a ton of work, and that's why we are hopefully looking to hire some more data engineers. And with that, I will pass it back to Levi on the third challenge.
Cool. Yeah. And then, after we get high accuracy biomass estimates from a forest, we can relate that to carbon credits that project has been issued. And then the challenge becomes, okay, how do we track that carbon credit from issuance all the way to retirement, confirm that it's only ever retired once, and then also keep the chain of command, essentially, I guess, lineage of that carbon credit. So we built our own carbon exchange, which you can think of it as the equivalent of a stock exchange. It's really an accounting system with an ordering system layer on top, like the orders you put in determine transactions, essentially. So project developers can make asks, like I'm asking $5 a credit for this project. Here's how many are available. Here's the minimum that you have to buy. And then people can place buy orders or bid orders saying, okay, I'll buy that project at that price. That'd be a buy order, like a market buy. And then with all those orders, those can start clearing. The exchange can match those together, then clear them, and then execute the trades and deposit and transfer the credits and cash into appropriate accounts. So this gets really important for when we start talking about something that people I think are generally concerned about, again, with forest projects, are double counting to make sure that each credit issued and retired maps 1-to-1 with a ton of carbon stored in a forest. Because you don't want to be saying issuing, say, twice the amount of carbon that's actually captured, because that's not actually helping climate change. That's just helping people feel good without any impact. So you want to keep those mapped together really tightly. And then, so our exchange too is also kind of core for making this process easier for other people. So we're building it on a public API, so we can start integrating with other platforms that want to offer carbon neutral services, and then also integrating with the various carbon registries to automate some of these transfers, because the overhead's quite a bit, pretty high right now to go into the different registries to execute transfers and retirements and things. We want to be able to just make this extremely simple for everyone and not have to worry about all of this tracking of serial numbers of carbon credits across the life cycle of a carbon credit. Yeah, and then with that, we are hiring. So we do have a few positions open, and it seems like we're opening another one up every month. But right now we have a machine learning engineer, senior software engineer, head of project finance, and a new project lead. And that one is more on the supply side, going and finding forest projects around the world to help get onto our platform. And I'm happy to take resumes or conversations directly from my email, l@pachama.com, or you can apply at this link. And I'll post this in the chat too, so everyone has an actual thing they can copy. But with that, I'd really like to take it over to questions and just let it go from there.
Awesome. Thank you so much, Levi and Sam. That was really, really fascinating. A bit of housekeeping for the Q&A. So a few people pre-submitted questions, so I'll start with those. And what I'll do is, if you asked a question, I'll ask you to unmute your mic and ask it yourself. If you don't want to do that, if you prefer that I ask it for you, just type it in the chat. And then once I've gone through those questions, we'll start going through some other questions. So please, so we can keep it orderly, just write your question in the chat. And again, I'll ask you to unmute. And if you want me to ask it, just say, put my name in all caps before the question, and I'll ask it for you.
And then I'll add too, just real quick, it doesn't have to be technical and on Pachama. Feel free to ask any questions related to us, our background, how we got into climate, maybe advice if you're looking to make the jump into climate tech. Really, anything's open. I think me and Sam are both pretty open books when it comes to this stuff. So we just want to be here as a resource for all of you.
Awesome. So for the pre-submitted questions, hopefully I don't butcher anyone's name too badly, but Magali had a question. I don't know if you want to ask it yourself or...
Sure, sure. And that was a
Awesome.
pretty good pronunciation, first pronunciation.
Yes.
Megan.
Okay, Megan.
So I don't quite recall the phrasing that I used, but if I remember correctly, it was something along the lines of what challenge or what's the biggest challenge you're encountering as software engineers working in climate tech, specifically at Pachama or more generally in the field.
That is such a good question.
Yeah, I'm having to think about that.
No worries, take your time. We can loop back around to it if you want as well.
I think one for me is I think people are hesitant to, in general, engineers are hesitant to jump to working in climate tech. I think there's this surrounding stigma of like you have to kind of know it all, like you have to know all the science and you have to be like a climate warrior to get in and contribute. And that's not true at all. Like before I joined Pachama, I was like, yeah, this is super important to me. But if you told me what a carbon credit was, I'd be like, what the hell is that? You know, so you learn so much of this on the job. And I think that you just have to go into it with a little bit of eagerness and open mind and be able to plant your feet and say, yeah, I want to work on climate technology. And then all the other stuff you'll pick up along the way.
Totally. Yeah, I would echo that. I mean, it's really like any other niche that I don't think anyone expects you to fully understand the intricacies of ad networks or stock exchanges to go work in the ad or finance industry, right? And I don't think that's the case here either. I will say that there is a ton of domain-specific knowledge around remote sensing. I mean, I've been pretty intimidated working with all these people who have PhDs in remote sensing, and you know the literature goes back 30 years, and people are solving these really hard problems that I hadn't thought about before as a software engineer. So there's a ton to learn. Like, don't get me wrong, but it's approachable and it's interesting. It's fun tech, to be honest.
Awesome.
But I would say just the most difficult part from a purely engineering point of view is the just absolute quantity of data. It's an immense amount of data, and you have to do all sorts of things that you wouldn't have to do on, you know, I come from a natural language processing background, and it's text takes up a heck of a lot less space than than satellite imagery over every month for the last decade of the Amazon.
Yeah, and I'll say like the nice thing about being a startup in this environment too is like we get to make use of a lot of services that weren't around when, say, like even 20 years ago or something, when a lot of companies were being born. Like we get to use GCP and we can run on Kubernetes and all that stuff. So a lot of the hard work around operating software services, I would say, is gone, like a lot of the DevOps stuff. So while I wanted to like get into that as like a challenge, like that's not even like on our radar, I think, anymore.
Yeah, it's not, you know, it's with GCP, Kubernetes, and Apache Beam and Dataflow. I mean, two people can do what would have taken a 20-person DevOps team to set up, even 5 to 10 years ago, to be honest.
Awesome, thank you both. Marie Kazai had a question.
Hi, sorry. I did write my question. I submitted it, and I actually can't remember what it was, which is incredibly embarrassing. But I do have a few questions, if that's okay. I'm really sorry.
Whatever's on your mind.
Okay, so I'm a software engineer. I'm really keen to get into climate tech, but I basically don't have any experience in like remote sensing, machine learning, and things like that. What are some good resources that you might kind of suggest to kind of be a bit more comfortable in getting into the space, if that's an okay question to ask?
Yeah, I mean, I'm of the philosophy of really working to learn, I guess, using the workspace as your playground for learning stuff. Maybe I'm weird in that sense, but you know, my advice to you is just do it. You know, especially now, there's so many companies that are really just looking for talented, mission-driven people. The hard skills, like I say hard in the sense of like the technical skills of, machine learning or really anything else, like say you're developing a SaaS, those things can be learned on the job. But what's going to carry you through that is really just being connected to that mission. So I don't think there's any technical blockers really. Some companies will say like, okay, you need 5 years of like Python experience or something like that. But I think with like climate in general, I think most of the companies are just so open and receptive to engineers being a part of their team for the mission, not their specific current skill set, because those skill sets will change, after they join.
That's really great to hear. Thanks so much.
Awesome. Go ahead.
Good. I can take the questions that Archie just posted in Slack, not in Slack, in Google Meets chat. So yeah, the first question is, how do you formulate the ML problem? Regression is often harder than classification. Are you shooting for biomass prediction directly, or can you use deforested yes, no as a binary outcome? The short answer is we're doing both of those things. We actually have a biomass model which we use for all sorts of things, which is a regression model. Yeah, it's a lot harder, but it's also a lot more useful for a lot of different things. And that actually dovetails into the next question, which is how well do the models generalize across tree types? The answer is they don't generalize very well. So we have separate models for tropical rainforests, boreal forests, temperate forests, right? And they all have to be trained separately on different field plots and different data. So that's one answer to how we're accomplishing the regression task, which is harder. But we also built a generic deforestation detection model, which we use it's a much simpler model to run, and we can use it for monitoring and detect unplanned deforestation very quickly without running the whole biomass prediction model.
Awesome. Cornelia had a question.
Yes, and I think Levi more or less answered it already at the beginning of his presentation. My question was around whether you're only using remote type of information like satellite or drone images. And the answer is yes, and more or less goes to what just Sam explained. How well do these purely imaging-based models work versus, okay, do you do some cross-checking with sensors in that region as well, or it's just based on those images? That was the rationale behind my question.
And to be clear, it's not just images. Like there's a product called Jedi, which is a satellite-borne LiDAR sensor, which is really cool. And it's out of, I believe, a lab at NASA. Is that right, Levi? Is it NASA or is it a different? Maybe it's
pretty sure it's NASA.
NOAA. Yeah, it's NASA and NOAA. I think they have a partnership, but they produce their own biomass estimates, and yeah, we spot check ours against theirs. We hope that ours are better because we use the satellite imagery as well, but it's definitely nice to have a baseline, and yeah, there's lots of sources.
Okay, good, thank you.
Yeah, I think that too kind of comes back depending on like what we're trying to get from. Like the historical satellite imagery is really good for kind of comparing a project's trends to its region. Whereas like the LiDAR, gives you a lot higher fidelity. So that's really good for the high accuracy biomass estimates. So depending on the data, we have different models.
But it's only been scanning the world for the last 2 years, and it still doesn't have complete coverage. So yeah, it's really exciting. And there's new, the climate tech is going mainstream. There's a big project in Norway that is going to get even higher quality satellite imagery. But again, it hasn't happened yet. So we're kind of at the forefront.
Awesome. Let's go to Sandeepa. I think you had a question in advance, and you also have a new question in the chat, so I'll let you ask whichever one you want.
Sorry, I don't quite remember what I said.
No worries. Yeah, we can hear you.
Yeah, I don't quite remember what my question was that I submitted, but
Your question was, are there any tips for applying or learning cloud-based machine learning engineering in climate change projects?
Yeah, I mean, it's somewhat related to my question here as well. So,
Oh,
someone who's getting started and who's interested in the climate area, what would be some like projects that I could work on my own to get started that you think will be helpful in potential candidates?
Yeah, I can take a little bit about that. Something that I've noticed from reviewing a lot of resumes for our machine learning candidates is there's a lot of people with experience doing either academic projects, but there still seems to be a little bit of a gap with people who've done like deployed machine learning projects on, I think, infrastructure. So whether that's Dockerizing your models and figuring out how to deploy those, or actually hosting them, building a service around it so you can deliver predictions. I think those are really useful skills to get into, even if it's in a, just extending an academic problem that you worked on, of saying like, hey, I did all the analysis to build that prototype model. What would it take for me to Dockerize this and put a service around it, something like that?
Yeah, learn about TensorFlow serving, Redis AI, the more deployment side of things. If it's the ML engineer position that you're looking at, I mean, we also, we have scientists who don't do those things, and they train the models in a Jupyter notebook, and that's great too. But I think that's not necessarily specific to climate tech jobs. I think that's pretty true for the machine learning marketplace in general.
Yeah, that's a good call out, I think, on the research side versus engineering side. When I hear machine learning engineer, that's what I'm thinking, like someone that, can take the models and take them a step further and deploy them in a production capacity. Whereas when I'm looking at a researcher, that's someone who's going to really focus in on developing the highest quality model and experimenting with feature engineering, those sorts of things. So that's also something.
That's when we do like to see the PhD in remote sensing and forestry and that sort of thing, because that can be really useful on the research side.
All right, the last pre-submitted question was from Prince. I don't think Prince is here. If I'm wrong about that, send a message. But otherwise, let's just keep going through the questions that people are posting. I don't need to get in your guys' way, Sam and Levi. Why don't I just let you pick the questions you want to answer, and maybe if you want, you can let them ask the question themselves so that you can see their faces.
Yeah, sure. Well, we'll go in order. So Rohan.
Hey, yeah, thanks so much for the presentation. I thought it was really great. Yeah, so my question was just around, as you guys, what are your biggest limitations and concerns when it comes to getting your product to market? And I guess sub questions about that are, I guess from the marketplace side of things, maybe you're more selling towards businesses that have to handle all of the regulatory and policy barriers, and you don't necessarily worry about them. But I'd be curious to hear about those. And then the second follow-up to that is what are your remaining technical challenges that you're foreseeing in the next couple of years?
Oh, great question. I think so carbon markets, there are kind of two carbon markets almost. There's a volunteer, where there's companies opting in to volunteer to offset their own emissions, and then there's the compliance markets. The compliance markers, there is a lot more barriers and rules and regulations around the auditing, the reporting, and the retirement of offsetting there and what they have to offset. So I'll say on the volunteer side, it's a little bit looser. So the companies are doing their own auditing, usually with a firm, because it is pretty nuanced to do kind of the carbon auditing to understand the emissions of an organization. And then they make that public usually, and then they'll purchase the offsets themselves. In the case of really large organizations, they're usually putting out RFPs directly for hey, we need to offset this much, give us your best prices, essentially like that. So in that capacity, but I guess, going back a step further, I guess the biggest limitation and this is probably startups in general, is like defining what your product is. So for us right now, we're selling a lot of carbon credits, but it's, our vision is kind of much more than that. If you look at the landscape of forest projects around the world, there's only about 500 of them. That number maybe more or less now, which is not enough to really make a dent on climate change, and really not enough to even service the demand from companies wanting to opt in to offset their emissions. So there's a lot of barriers on the supply side to even get people into these forest carbon markets. So that's something that we're going to take some dart throws on and like trying to loosen that up to really get smaller landowners active in these markets and things like that. So, but yeah, that's like the typical kind of startup like challenges of like, okay, that's our vision, how do we execute that? But I wouldn't say there's so much like systemic regulatory or policy barriers preventing that. It's more of like us as a company, how do we define the organization and the culture to go execute on that vision?
Thanks so much.
Yeah, that's a great question.
I can take the next one really quickly. How is software tested at Pachama? Pretty similarly to how it would be tested anywhere else. We recently have kind of converged on a repository pattern and a domain-driven development, which has been really nice because we can have test repositories and run a whole suite of unit tests really, really quickly. But of course, we also, given the big data and the big data services that we're working with, we have a suite of really slow integration tests that runs as well. But yeah, pretty standard stuff.
Yeah, and then we run those in Circle CI for continuous integration and delivery, kind of normal stuff you'd see at a software company. All right, Steve, do you want to ask your question? Very staticky.
Yeah, not working.
All right, I can ask it for it. So it seems like carbon offset markets may actually function more like an energy capacity market than a stock market. And there may be quite a few advantages to follow that model. If you had monthly auctions rather than real-time trades, you could true up existing biomass before each auction, as well as guarantee different types of entities could have a chance to purchase offsets. Have you investigated an auction type system for the marketplace? That is a fantastic question, and it sounds like you should apply for our head of finance position. But no, that is something that we've had some of our advisors bring up as well. So something like we're looking into, but are mostly been focused on just getting the basics of the exchange stood up and the kind of traditional stock market capacity of like the order matching and executing the trades as quickly as possible rather than the timed auctions. But yeah, that's something we definitely want to look into in the future as well. So great question.
Naman, are you aware of good open source projects on climate tech and machine learning? Well, machine learning, yeah, everything's open source. PyTorch, TensorFlow, it's all good. Climate tech, Levi, what do you think about that?
I'm not sure off the top of my head.
Yeah, me neither.
I know there's a lot of different open source packages for like weather data. That seems to be a really popular like project for people to work on. So there's typically a lot of open source packages and things around it. But.
And GIS in general has kind of undergone a open source revolution over the last 10 years or so. It used to kind of all be owned by Esri and ArcGIS and that whole suite of tools. And now, at least in the world we're in, no one's really using that. There's, our chief scientists use QGIS, PostGIS, all these really good open source tools. So yeah, that's gotten good in the past decade too, but it's not climate specific.
Okay, thanks.
Sam, you want to take the next one too?
Yeah, from Benedict. Question from a newbie to satellite data. Aside from the huge quantity of data available, what work needs to be done to extract valuable insights from this data? Lots, unfortunately. Because it comes through, and I kind of alluded to this in the ML slide, but depending on the sensor, depending on the time of year, depending on the orbit that the satellite happened to be on, the terrain, the time of day, right? There's a tremendous amount of variation in satellite imagery of for a given place on Earth. So yeah, normalizing between there is necessarily a pretty intense normalization process before you can really do anything with the data. We're still heavily using an algorithm called Landtrender, which is something that's built into Google Earth Engine, and it's a kind of smart time-based normalization algorithm. But we're definitely experimenting with our own alternatives to that to get rid of the bottleneck of Google Earth Engine as well. But yeah, normalization and transformation, even just the geometric transformation gets tricky with all the different coordinate systems involved, and the geographic error too. There's oftentimes you'll have 10 squares that say they have the same bounds, but they actually vary by up to a few hundred meters, right? That's very common, and yeah, keeping objects invariant is another process that you have to do.
All right, Sam, do you want to follow up on the?
Oh yeah. I answered the first yes/no question, which was, hey, it sounds like you have more than enough unlabeled data, but is the availability of ground truth data a problem? And the answer is yes, it's a big problem, because the core problem, the core reason that Pachama exists is because it's not feasible to send a team to go measure trees once a month everywhere in the US, everywhere in the world. And yeah, we're not relying on that data as our sole source of truth, but it is our best source of ground truth. So yeah, the first way that we're trying to ameliorate that problem is by using slightly less accurate but still good versions of ground truth data. So for biomass, like I was mentioning, the JEDI-based biomass model is a pretty nice way to at least check our model, but we don't consider it ground truth. So short of better ground truth data, now we're looking at things like semi-supervised learning and transfer learning, which is stuff that we've definitely been playing with. Luckily, you can use even just a basic ImageNet trained model can be used for transfer learning, even though the types of objects that a YOLO type model is detecting are nothing like the objects that we're detecting. Those first few layers of the neural net will learn edge detection, color detection, that sort of thing, and it's still useful to supplement our small amount of data a little bit. But that's kind of the core of the problem.
Also, if you have access to any data, forest data, let us know, and please send it to us.
We always want more forest data.
I have a related question. First, thanks a lot to Levi and Sam for the presentation. It was very interesting. I was wondering, regarding the evaluation of your algorithms, given that there are very few ground truth images to evaluate them on, like how do you ensure that you don't overfit a given region in the world, or only trees in the US? Like, do you have some evaluation sets that are specific to some regions, or do you wish to create them?
Yeah, we have that, and that's a huge problem, is overfitting to a given ecosystem. I mean, we have models that we know are overfit to the northeastern United States, ones that we know are overfit to Brazilian Amazon. Yeah, we can quantify how badly they're overfit by testing them on the other data, but fixing the issue is a little bit harder.
Yeah, thanks.
All right, Josh asked, why is ML better than hand-developed remote sensing models for forest monitoring?
Good question. Why? It is.
I think we'd have to defer to our
Elias
for that one. But I do suspect that it comes into once you start looking at point clouds with LiDAR data. I don't even know how you would hand develop a model to interpret that data, but maybe you could.
There's definitely hand-developed like feature extraction and normalization layers that happen before you throw it into the deep learning. I think that the process to take the LiDAR point cloud and the topography data and get canopy, I don't believe that's actually a machine learning process. It's some pretty heavy math, but yeah, especially with all these data sources, it would be pretty tricky to build a hand-developed model, I think. And there are people doing it in academia, and if you're interested in that, we can totally put you in contact with Elias, who has that background.
Or if you're really interested in it, you can come apply.
Do it, yeah.
All right, Julia, do you want to ask your question?
Sure. I'm a product manager and I've just joined Work for Climate yesterday. And I've already connected with a bunch of other product managers who seem to be trying to figure out, what do I do? I want to do anything in climate. How do I get into it? So I know you guys are both software engineers, but I'd be curious of your thoughts, just kind of generally how product managers could get into this space. And also I'd be curious just to hear a little bit more about like the future of where you see your product going as well.
Yeah, for sure. Well, I guess you definitely joined the right crew over at Work on Climate. So I think that's going to be a fantastic resource for you as you're kind of branching out and looking in to work in climate tech. But, again, my advice is like, just apply and jump. Don't worry about trying to learn all of the different things, because there's like so much to learn. And the most important thing that's going to, propel you forward is just being able to again, like plant your feet and say like, yeah, I'm going to work on climate change and then go do it. But all the science, the technology, everything, you'll pick it up on the job. That's any of us who have joined a new company like, oh yeah, I guess there's a lot to learn, and that's part of the process. So outside of the work on climate, I mean, really just being proactive about finding, researching the companies and finding one that you really connect with and not letting them say no. So, I don't know if I have anything more specific for that. So, but I hope that answers your question.
Sure. And then I was just curious too about kind of where your product's going. I know you talked about all the things you're doing right now, but just kind of looking out, a year from now, like where do you guys see yourself going?
Yeah, absolutely. So I would say our current product on the, user facing side of things is really focused on individuals and just like, hey, buy a credit from, these groups of projects or something. But we're going to start really more focusing on organizations and building that as like the place for them to really craft together their proposals and connect with the project developers to purchase credits, hopefully in a more intimate way. Right now, there's like a lot of hands that carbon credits go through to get to someone that's actually going to buy them. And then also probably building out a lot more features for the project developers themselves too. It's like giving them the tools in their hands to make it a lot easier to manage their own forest projects and the carbon credit issuances and get their project listed on the platform, request an audit, remote sensing verification of their project, sign up for disturbance alerts to say like, hey, there's like an impending fire within 50 miles of my project, or someone cut down 10 trees in like this circle of my project. Those sorts of things. We really want to provide those tools for people, not necessarily just be a marketplace where we're buying and selling carbon credits. Because we don't think like that's where we provide the most value. We think the most value we provide is by developing this technology to make this whole market a lot more seamless and smoother for the project developers and the buyers. All right. Steve asks, are there any U.S. states currently looking into integrate carbon offsets from forest projects into their RPS standards? I wish I could give you an answer on that, but I really don't know. Yeah, so we do have a kind of, I don't know how you describe Cindy's title, but sustainability expert that kind of handles more of this. Yeah, she would probably know that. She used to work at Climate Action Reserve specifically for forest projects. So, but yeah, I don't know off the top of my head. So sorry about that, Steve. Well, we have 6 minutes. Is there any other questions that people have, or comments, thoughts, concerns, whatever?
If no one has one, I'll ask a question. I'm going to be full of non-technical questions. You mentioned illegal deforestation in your presentation. I was kind of curious how much of an issue is illegal deforestation versus, say, forest fires versus diseases in forests versus other issues that come up. If you have any perspective on that.
That's a great question.
Great question. It depends on the region too. I mean, illegal deforestation is a huge deal in our Brazilian projects. Less of a big deal in California and New England. Obviously, wildfires and tree death from diseases are a big problem in North America. But yeah, Levi, do you have any more specific things to add to that?
Nope, that's what I was going to say. It's it really depends on the project. And one thing that's interesting is a lot of the projects, their carbon credits will kind of be priced depending on like how much risk there is for the project. So you'll see U.S. projects are usually a lot higher priced because we have a lot of structure and protections for forests, and we have clear land ownership, titles and going back for a long time, and we have court systems and things. And we start going to some of these like smaller countries or around the world, some of those systems may not be in place, or they may not be like the same standard as in the US. So you see their prices drop quite a bit. Or if there's like in Brazil, like heavy deforestation and encouraged deforestation, you see the prices of the credits drop. Anyways, yeah, it was just an interesting side note.
Definitely. Have you ever seen something that's really surprised the project managers and had to like downgrade the quality of their carbon offsets, etc.?
I don't know, maybe not surprised the project managers, but we have seen instances where one of the like accepted projects that had credits issued to it, there are clear of like them, like the land was clear cut, and then the boundaries of the project were like circled around individual trees that like were in ravines and things like that they couldn't get machinery to. So it was pretty like sad to see that stuff, but also kind of reaffirming to us that like we do need this transparency, because a project like that went through the entire regulatory process to get carbon credits issued, and they were selling carbon credits. But when you actually like look at a picture of the project, it's like, wow, the land was cut, and this project is these like little islands of trees and deep ravines, or actually some of them were actually on an island that was like a big mountain that they couldn't harvest from. So so yeah, there is like some surprising things that we've uncovered just by going through the review of these projects with, and that wasn't even like an ML model. It's just us looking at a picture.
And we routinely reject applicants, project applicants from our system too, which is kind of crazy that they're off selling climate credits and they have these pretty glaring issues that show up when you do some remote sensing, even just looking at the data. We got a +1 on Josh Daniels' question, which was, why did you guys decide to work on forest? Forest climate stuff out of all the areas of climate work available? Us personally or Pachama? I mean, it's Pachama's mission, so that's probably
you personally.
Honestly, it was almost a revelation that I could use these data engineering, machine learning skills for climate. I didn't know prior to seeing this whole world and talking to Diego and Tomas at Pachama that there was even an opportunity to bring my machine learning skills to the climate. So for me, it seemed like an obvious choice, and I was pretty happy to find it.
We made Sam drink some Kool-Aid before he could actually join the team. So that helped.
Some mate.
Yeah, some mate. I'll say for me, there's a book that really had a profound effect on me. It's called 1491 by Charles Mann. Highly recommend that book. That was pretty eye-opening because so I live in Missouri, and when I was younger, I would go to a lot of powwows for like Cherokee tribes. I'm 1/8 Cherokee, not much, but I try to connect with that cultural heritage. And being able to read that book, and there's this story of like the colonists coming to the shores for the first time and walking upon the land and just being blown away. They're like, wow, there's so many like fruit and nut trees. Like it's so plentiful here. Like they didn't realize like they're essentially in a large orchard, and it was this specifically manufactured and tailored environment. That the environment thrived and the people living there thrived.
Yeah.
And I always saw that as a way, like, we could totally get back to that. Like, we don't have to see this thing of like us just demolishing things and building structures and then innovating our way out of, you know, every crisis. Like, we have a lot of those things at hand, and we just need to recognize their value and promote their use. And I see forests as a huge way of doing that.
Yeah, no, same here. Especially, I moved out west 6, 7, almost 10 years ago now, and I live in the Rocky Mountains now. And we're undergoing just absolutely massive tree death from beetles all around the Rockies and the Sierras, and it's something that I feel like doesn't even get talked about very much. But it's something that every time I go out hiking, I start to see, you know, a third of the trees that are just dead. So, you know, that had me thinking about forests, and yeah, we need.
That was a great answer. We are at time. Levi and Sam, up to you if you guys want to stay on for a few minutes and keep chatting, or otherwise, I'm sure you have plenty of trees to go save. But for the people who do need to hop off now, I just want to say a few words. First of all, thank you so much to Levi and Sam, and thank you to you all for attending. I'm going to be creating a thread in the Slack in the hashtag share your path channel. And if you learned anything from this conversation, please post it there, start a conversation about it. Let's keep the conversation going. And if you're not yet part of the Work on Climate community, if you're joining from somewhere else, I would highly encourage you go to workonclimate.org and join the community. So thank you very much, all. And Levi and Sam, I'll let you say any last words that you want to, or if you want to stay on and answer a few last questions, that's fine too.
Yeah, I'll just say, you know, thanks for letting us come and talk. And, you know, we are hiring, as we said multiple times, and yes, remote roles, all the roles are remote, and outside of the US is okay. But yeah, if you're on the fence, just apply. Don't think about it, just do it, and be happy to talk more. I'm also in the climate group. I'm pretty bad about responding, but the messages will get to me, and I'll respond to you if you want to reach out to me.
Yep, same here. In the climate group, I will get back to it at a certain point. But seriously, thanks for your time listening to us ramble on today. And you know how to reach us if you need anything. And yeah, hit that lever link and apply if you're remotely interested, because we're really interested in growing our team.
Awesome. Thank you so much, guys. And I will post the recording for everyone to view after. All right. Well, I will see you all next time. Thank you.
See y'all.
See ya.
Thanks, Sam.